computer scientist from the Computer Security Division at NIST. Peter is definitely an expert in this area, so this is going to be an action-packed session. With that, I'll hand it off to my good friend Pete.
Am I on? Mike, good? Okay. It is a pleasure to be here. My name is Peter Mell. Ron Ross is one of my heroes. He got his own name plaque, and he even got his own fancy chair. And so they asked if they needed me to take away the chairs, and I said, no, I can be like Ron Ross and have a name tag and have my own chair. I should have written my name on the back, though, but you know who I am, and it doesn't really matter. So back 2 years ago or so, I was looking at what is cloud computing, working on some definitions. I got in trouble with my management for giving a talk that defined cloud computing because, well, no one can agree what it is. And a little while later, an iteration of my definition took hold and became the US government's definition. That definition now has been submitted to the International Standards Organization for international standardization. And it's kind of exciting, but it's kind of sad to do a whole year of work and have people only remember 2 pages that you wrote. But that said, when I first started doing the cloud definition, and I was really excited about cloud, and I was saying, hey, this is what it is, there was an old guy in the back of the room, one of those smart people, right, with the beards. And he came up to me afterwards and he said, Peter, there's nothing new here. You know, this is a punch card kind of guy. And I said, you know what? In a way, you're right. And so I ask you today to think in your minds about what is inherently cloud security. What is different? What is new? So I asked myself that question. I recently went to a cloud security boot camp just to see what industry was doing for cloud security. I looked through the Cloud Security Alliance's security controls, not the new ones that came out a week and a half ago, but the previous ones. And I said, is there something new here? And well, you know, there's a lot there. Big document, I think, was it 88 security controls? Is there that much new to learn in cloud? And then I remembered something. I remember years ago seeing a matrix showing all the cloud security controls mapped to security compliance frameworks. ISO 27001, 853, PCI DSS. So I pulled up that old work, and I just validated to myself that every cloud security control was mapped to a security control in a general purpose security framework. And the answer was, with the exception of the PCI DSS, the answer was yes. The mapping was complete. The mapping, though, was a one-to-many mapping. So for every cloud security control, there were many general purpose controls that covered it, which meant that at a security control level, while there may not be a need for a new control, certainly there's a new idea or a flip on an existing idea that then mapped a domain-specific thing like cloud to multiple general-purpose security controls. And so while Ron Ross is right last hour when he said we're not going to create, you know, all new security controls for cloud, it is worth looking at cloud security controls because we need to apply them in clever and creative ways. And so how do we know what those are? Oh, by the way, we started late, but Parm said I can have an hour, so you're stuck, okay? Just to let you know. So I'll end about 5:40. That gives you 20 minutes to go brush your teeth and come back for drinks. Open bar, by the way. Let's see. So I ask, you know, where can we find out about these cloud security, you know, unique attributes? Well, there's that definition that I wrote. Oops, I'm not supposed to touch the computer. Huh, I got it, guys. And it messes up their IT. So there's the cloud definition that I wrote, which is, by the way, we finalized. We had to finalize really fast because it was being submitted to the International Standards Organization. So look for the final version of that. And I've given talks before on how this definition demonstrates sort of security principles. But then also, with that, NIST published a cloud reference architecture. And so in this presentation, I take the cloud definition, I take the NIST cloud reference architecture, kind of put them together, and then ask, what are the new and novel cloud security attributes? So let's do that. So here's the NIST cloud definition. At least the top is the first paragraph of it. Cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. So that's a nice synopsis, I think, but those essential characteristics, I've always argued, are what give cloud sort of its momentum, its push. All the vendors in the world can say they are cloudy, but unless they implement those essential characteristics, from a technical perspective, they're not going to achieve the benefits that are going to give them the cost savings, power savings, green savings, scalability, and agility that cloud promises. But this is supposed to be a security talk, so we won't discuss that. But in the context of the reference architecture, we'll look at those essential characteristics, we'll look at the service models, we'll look at the deployment models. By the way, has anybody ever heard me talk before? Okay, some of you, okay. Okay, good, I don't have to worry about telling the same story twice. Now, I went around and took the cloud definition and security kind of abstracted principles, and I talked to a lot of cloud vendors. And initially, I was very frustrated about one thing, and that was that even though everybody liked the cloud definition that I wrote, most of the vendors did not adopt it completely. And at first I thought there was something wrong there, and then I realized, oh no, there is something right there. And what I found is that there is often a trade-off between security and cloudiness. And those vendors that more fully implement the cloud characteristics also more fully experience some of the cloud security challenges. And so in order to add some security, many of the cloud vendors sort of scale back their cloudiness, which, by the way, raises the cost, but then provides security. More recently, I'm sure you've seen lots of vendors are coming up with government clouds, GovCloud initiative, be it Amazon or Google. Another major SaaS provider came up to me and said, Peter, agencies are telling me I need FIPS 140 encryption. What is this? And I talked with the lady about it. I explained to her the government requirement. And I said, do you realize, though, that as a resource-pooled system, if you're going to adopt government requirements, you've got to throw out all of your existing encryption, and you need to replace it with government-improved encryption. Now, I said, I'm not recommending this. I'm just saying, this is the decision. If you want your big resource pool to be sold to the government, that's one thing of many you'd need to do. And that's sort of when the light came on for her that, oh, a government pod or cloud would be appropriate. Okay. So, now, conversely, though, oh no, not my picture. See, he's following me. Look at that. Conversely, I really argue that cloud can have security advantages. In fact, as challenging as cloud has been in the security area, it is possible, hypothesis, that cloud may be the answer to many security problems. And so the argument kind of goes like this, and that is that cloud computing itself is complicated. I admit that. But so is traditional IT. And your existing data centers are full of a bunch of very complicated enterprise stovepipes. And each of those has different software, different operating systems, different applications, different standards that they use. It requires different sets of administrators with different talents. And the complexity is through the roof. And the ability to do really in-depth security on any one stovepipe is limited because the security resources are spread out among all the different stovepipes that are all different. Well, we'll get to it in a minute, but cloud is different. Cloud is resource pooled. Cloud has an abstraction of homogeneity, which means that while you might have a single complicated security model for a cloud, it's just one model. And if you make that cloud as cloudy as possible, you're going to make that resource pool really, really big, and you can focus all of your security resources on that one model, hire people that are competent in that one model, and do everything you possibly can to secure it. To the point where one major SaaS provider sat down with me and showed me in depth their security model. And we went through basically penetration tests, on paper. And it was really, really good. It was multi-tenant, but it was really, really good. And so how will it balance out? Is cloud more secure? Is it less secure? The answer is, I don't know today. And a lot of it resides on these principles that we're going to discuss and sort of how they flesh out. So here is the NIST cloud reference architecture without its details. These are the actors. It's pretty simple. You've got 5 actors here: customers, providers, carriers, auditors. That's self-explanatory. What in the world's a broker? A broker can take many forms, but basically an organization that is an intermediary to getting to a cloud service, maybe provides a security front end to it, possibly. It could be a service that gives you the ability to put in a request for a cloud, and it gives you multiple clouds you can buy from, and you choose which one you want. It could be a service that aggregates multiple clouds together into a single kind of cloud interface that you use. So in this discussion, we're going to assume that the consumers are stupid and that they're malicious. We're going to assume that the auditors don't have any good way of grabbing technical information on an ongoing basis from the cloud, which they don't. We're going to assume that the carriers are also entrusted and compromised, and that the cloud brokers cause a whole bunch of supply chain and composed complexity kind of problems. And that's all true. And then the cloud provider has a lot of security complexity, which we'll jump into. Is this addressable? Yes. Is this addressable by the security controls we have today? Oddly enough, yes. So, essential characteristics. So here are the essential characteristics that we identified long ago. And the on-demand self-service aspect certainly enables people to circumvent the CIO shop. Program offices can go and get what they want when they want it, and that's a danger. The on-demand aspect means that if a CIO shop offers cloud services, it's got to be on demand. So when the customer wants it, when they access it, when they get it, it has to be pre-secured. So the upfront cost for a CIO shop exists there. Broad network access, we're accessing it from lots of different devices. Resource pooling is the key. When people kind of take my cloud definition and draw diagrams of it, at least the Cloud Security Alliance especially, They put the resource pooling as a foundation and the other 4 characteristics on top of that foundation. And I agree with them. I think that was a brilliant thing for them to do. And so when you have all those other 4 characteristics using resource pooling as a foundation, it really hits home the point that you've got all your eggs in one basket. If the basket breaks, that's a problem. But boy, can you secure that basket, at least on a public cloud. Think about a private cloud for a minute. And I have a slide on this, but I love jumping the gun on things. Think about a private cloud. You're not going to do away with your current data center. You're probably going to start a pilot. You're going to get 100 machines. You're going to cluster them. You're going to provide some on-demand interface for it. You're going to start moving some applications over to it. And guess what? You're going to have the same security complexity that you have in your existing data center, plus you have to secure this pilot cloud system. Your resources are even further spread out. And so notice then that the private cloud possibly has less security devoted to it than that really large public cloud. But then also think about the threat exposure of it all and think about how the argument gets reversed. We'll do that in just a minute. The rapid elasticity certainly promotes availability. However, especially on the infrastructure as a service side, you have to program the apps to take advantage of this new availability. Are people doing that? Yes, some. Do I hear government agencies by the droves coming up with answers? Are porting their existing solutions, rewriting them so that they're service-oriented and can take advantage of the rapid elasticity of a cloud? I haven't heard many of those stories. I know on the commercial side, commercial vendors have done it for sure. Measured service. That characteristic got there because one of the agencies we know and love tried to create a cloud, or did create sort of a cloud before cloud was even existed. And they wanted to increase their server utilization. They had like a 15% utilization, and they said, hey, we're going to create this cloud. They didn't know the term back then. And so they created it, and their server utilization went up to 85% or 80%, you know, the ideal. And guess what? More work wasn't getting done. It turned out the developers were using all the resources that they were allowed to use. So that measured service characteristic is essential for the availability of the cloud, so that people only use what they need to use. Okay, so here is the NIST cloud reference architecture. It's not complicated. We will dive into some of it. Notice, though, that on the cloud provider, we've got some service layers. And so you can compose clouds within a cloud provider. You can build a software as a service on top of a platform as a service, for example. But then you can also use the cloud broker to aggregate cloud services. And so there's sort of 2 ways diagrammatically to look at composing clouds together. And again, we're going to assume that pretty much everybody except the provider is either stupid or malicious. And I'm going to argue to you that you shouldn't use a cloud unless you can assume that the consumers are malicious and that the security model is strong enough that you're still willing to use the cloud. When I first started talking to government executives about cloud, back when Mr. Kundra was first in his position, the first federal CIO, the argument was, well, I need to make sure that only trusted users use my cloud, because if they don't have good security, then that puts everyone else at risk. I don't think that's a good answer, because even with a private cloud, it's multi-tenant. You have multiple business units, people you don't know, people that aren't going to always do things right. And it is possible to build clouds so that you can assume that the user is malicious and you separate the users, and it works. Okay. Let's see. The cloud carrier, again, let's assume it's malicious. You know, a cloud provider may use the carrier for denial of service protection, possibly for some encrypted tunnels in certain limited cases, but let's assume it's malicious. And then we're going to go to the provider. And notice here that, and here's my main point, there isn't obviously a single security model for cloud. There couldn't be. You see here 3 different service models, lots of different applications for those service models, meaning we're going to need lots of different security models. But there's hope. We can still talk about foundational cloud security mechanisms, even though we're going to have a diversity of models here. So putting it a little bit simpler, so here is part of the cloud provider stack on the right side, mapped to the service models in the middle, the software as a service, platform as a service, and infrastructure as a service. Does anybody want me to explain the service models? Don't be shy, good. Okay, mapped to typical people that might use them. Okay, so by the way, the diagram makes it look like the resource abstraction and control layer is common among, no matter which service layer you use. Nothing could be further from the truth. Software as a service architectures look very, very different from infrastructure as a service architectures. And platform as a service architectures still aren't mainstream enough that, at least I've seen the real internals. And I'm sure they're different too. Okay, so here's the service models. Security observations. Certainly you've gone to a talk where people talk about the differing degrees of customer responsibility. That at the infrastructure as a service level, the customer is responsible for the virtual operating system on up. That at the software as a service layer, they're typically responsible for which users are allowed in to represent their organization. And platform as a service is sort of in between. Have you thought about the different types of multi-tenancy, though? That there's really 2 types of multi-tenancy. There's data multi-tenancy and processing multi-tenancy. And did you notice that not all types of multi-tenancy apply to all clouds? So software as a service does not have processing multi-tenancy. Customers do not put their processes on SaaS clouds. They do put their data there, but processes are known to be able to attack processes. But data by itself, without being executed, is inert. Data doesn't inherently attack data. And so we have this processing multi-tenancy challenge at the PaaS and infrastructure level that we don't have at the SaaS level. So does this mean that we as a government or governments should then adopt SaaS? Is that the answer for the security? Well, not so fast. Notice with software as a service that the attack surface is huge. You know, before, even when you put your applications on the internet, like my time and attendance is on the internet now, right? But at least this is comparing to public clouds. You know, only the authorized users in my agency are allowed past that login portal. With a public SaaS, anybody is allowed past the login portal, and they have access, think about this, to every single screen in the application, every widget, every knob. The attack surface is huge, which means it's much more difficult to secure than a system where you're just trying to secure the login screen. But I have to admit, the processing multi-tenancy issues are difficult. At the infrastructure as a service layer, we typically rely on hypervisors. Hypervisors typically have around 1 million lines of code. Okay? According to Bruce Schneier, for every 1,000 lines of code that are written, there's one security fault. Now, I don't know if that's before they fixed all the security issues or after they fixed them. But in 1 million lines of code, there's probably some left over. You know, I started the U.S. National Vulnerability Database, so I spent years cataloging vulnerabilities. And before there was enough funding, I did it myself. And pretty much any software out there is vulnerable. I had a company from another country, and I won't name the country because I don't want to make fun of that country, but the company said, "Hey, Peter, our product's not in your database." And the answer was, yeah, but no one knows about your product. If anybody knows about the product, they find vulnerabilities and it goes in the database. So pretty much, hypervisors probably have security issues. Now, we've been using virtualization for a while. It's accepted, okay? It's nothing new. But remember I said that while we don't need new security controls for cloud, we may need to apply them in new and interesting ways. And here's the kicker. We are using virtualization in a very new and interesting way. In an infrastructure as a service cloud, that 1 million lines of code represents our new front line of defense. It is the equivalent of the enterprise firewall in the cloud paradigm. It is what separates the potentially insecure customers or malicious customers from each other. So, can we trust it? I'm waiting for a response. I don't know. Do you? You know, it's one of those things where, you know, we're doing it, and we're making risk-based decisions about what level of sensitivity of data we're going to put into that architecture. We're doing that every day. And certainly many people are putting certain degrees of low sensitivity data into infrastructure as a service clouds that rely on hypervisors as their frontline defense. And you know what? I guess we'll know in a couple of years. You know, that's my only answer. So here is a slide that shows, an ugly slide, that shows clouds composed on clouds. And I put this up because when I first made this slide, I didn't really believe that clouds were composed on top of clouds. I didn't think somebody would build a cloud on top of a cloud that was built on top of another cloud. And boy, was I wrong. You take the massive public cloud providers, and you take a lot of small innovators who don't have much money, and what are they going to do? They're going to build a novel cloud solution on top of a cloud. And when you do that, think about the security controls. Now who's responsible for what? And now how in the world are you going to get the visibility into that? And now we have an interesting version of supply chain issues. We're not talking about a physical supply chain here. We're talking about a service supply chain. And getting the transparency into that supply chain is a real challenge. Okay, don't touch the laptop. If I touch the laptop, it messes up their voice recording with the slides. So I keep touching for it, and then I can't. Okay, deployment models. People in government seem to assume that private is more secure than public. And that annoys me, because it's not that easy. They make the case that private clouds have less threat exposure than public clouds. And in general, they're right. But does that make them more secure? No, that property does not make it necessarily more secure. And so between private community and public, you typically go from very small clouds to very big clouds. And as I argued previously, as you go from small to big, you're able to focus more security resources on that single security model. Thus, you have a chance of having greater security the bigger the cloud. So, what's the answer? Is private more secure than public? And the answer again is I don't know. And certainly for a small business that doesn't have very good security, can't build great security because they don't have the money to leverage a large cloud provider's security sounds like a very reasonable thing to do. For a government agency with low sensitivity data that doesn't want to spend a lot of money serving up that data, a public cloud sounds very sensible. Due to the myriad of security issues that need to be dealt with in the government in sort of a special way, we do things a little differently. It's hard for high sensitivity data, I think, to get all those controls that we need, all those settings that we need, all that encryption that we need and identity management that we need. I think it's hard to get that today in many public cloud providers, which is maybe one reason we're moving towards private. Another thing, though, may be simply that we've always been adopting virtualization. And as we virtualize our processing and our storage and our network and our data centers, we're realizing that we can add an on-demand interface to it. And lo and behold, every year our data centers are getting cloudier and cloudier, which makes it very easy for us then to transition to a private cloud, at least to pilot it, and we control all the security, so it makes us feel comfortable. Are we more secure? I'm not sure, but it certainly makes us feel more comfortable. And can we check off our boxes that we did everything we were supposed to do? Yes, we can. Okay. Now, so that you don't think I'm stupid, clouds also often have these characteristics, but they're not definitional, so we didn't add them to the definition. Virtualization, not all cloud providers use it. A lot of SaaS vendors don't. SaaS vendors, from what I can tell, tend to resource pool in 3 different layers. So they do some load balancing and some web front end, resource pooling, some middleware, resource pooling, some database back end, resource pooling. But they don't try to resource pool the whole thing together. And thus, virtualization then adds sort of an extra overhead that they don't need. Some PaaS vendors just don't use virtualization. All you really need for a platform as a service is the ability to encapsulate the running code. You know, you want to use a Java sandbox? Go for it. You can do that. At the infrastructure as a service level is where virtualization seems to be almost universal. Clouds typically use open source. If you're going to have a big cloud, you certainly don't want to pay for all the licenses. And so that brings up discussions that we've always had about open source versus commercial. Certainly geographic distribution is an issue on the big cloud, service orientation. The homogeneity is based on the resource pooling. So clouds present an abstraction or a reality of homogeneity, which makes that security model simple, which means you have all your eggs in one basket, but it enables some resiliency there, because if something goes down, you've got a perfect clone of it that's still up. Okay. Under cloud service management, there's 3 categories, and I'm not going to go deep into these, but we asked ourselves, what's new? What's new in the cloud domain? And certainly in the area of the business support, where you are working with the customer on the cloud management, certainly on when you're working with a customer on provisioning and configuring the cloud, and certainly if we ever get to it, that portability, interoperability interface where we're supposedly someday going to be able to get our data back out of the cloud without much work. You know, all those areas of customer interaction represent new areas of security for that domain that we're going to have to address. So just highlighting areas of need there. New vectors, if you will. SLAs, I'm sure you've heard talked about a million times, so I won't go into it very much. So I'll just let you read that for a second, and I'll jump forward. Okay, cloud brokers. There's 3 types, according to the NIST reference model. There's arbitrage, that allows you to have a menu of cloud providers you want, and you say what you want, and then they give you the one you want. Intermediation, where there's a service built on top of the cloud that you use, and aggregation that pulls multiple clouds together into a single service, kind of a mash-up kind of cloud, to use that abstraction. And the broker certainly adds a lot to opaqueness. You know, how are you going to get the transparency that you want when you're not even directly accessing or working with the cloud provider? Certainly, there's more just distribution of the security responsibility, so that adds lots of issues there. And we talked about the whole idea of service and supply chain. Okay. So what about the poor auditor? We talked about FedRAMP. At least Ron Ross mentioned it last time. The idea of the entire government working together as a single customer to evaluate the security of large cloud providers. And FedRAMP, by the way, for the government to use public clouds, FedRAMP has to succeed. It's not possible for every agency, every bureau within an agency to be independently analyzing the security of a large public cloud and requiring their own unique security policy. Because there's bound to be 2 policies within the government that contradict each other. And the cloud provider has to simultaneously implement all the security policies of its customers under that model. It's not possible, and they won't do it. What they will do is they'll build us a government cloud, one cloud for the government to meet our needs, but because of the resource-pooled nature of cloud, they're typically not inclined to customize it or able to customize it for each individual entity. So getting back to the auditor then, we're going to have these big clouds, and we're going to require auditors to audit them, and they're going to go in every day? No, certainly not. Every week? No. Every month? No. Maybe once a year, every 6 months, possibly. And they're going to find out in a snapshot of time for a sampling that things look good. But what we really want to know, we want to know on an ongoing basis, day to day, is this cloud being maintained securely? Is my usage of the cloud secure? And so to do that, we need new tools. So we need, ideally, the auditor to go in and validate that the monitoring tools are working correctly, and then we go and watch the output of those monitoring tools on a regular basis. In our first attempts at this, I think some people in government have asked cloud providers for detailed security logs that show actual vulnerabilities, and the cloud providers have been reticent to provide those. And for good reason, because they've got lots of customers on that same cloud. It's a multi-tenant environment. And other countries, for example, may not want our government knowing an actual vulnerability that can be exploited in the cloud. Possibly what we need is the ability to take sensor data, to aggregate that data together, to analyze it, to provide reports and visualization for actual operations, but then to abstract that data and bring it up to a higher level where it's abstracted and of a less security sensitivity, and that we then provide to the cloud customers. And that would enable the cloud customers to get the warm and fuzzy, that things are being maintained securely, without revealing sensitive security details, which would be kept in the cloud provider's realm. So this is a topic near and dear to me because a year and a half ago, I had an unusual opportunity to have breakfast with the federal CIO, Mr. Kundra. And he asked me, he said, Peter, how do you do continuous monitoring for cloud? And so I did what any of you would do. I said, well, I'll go look into it. And I went back to the desk and realized I didn't know how to do this for a traditional IT enterprise, much less for cloud computing. So what we did is we decided, hey, let's solve this problem for a traditional enterprise. And then let's apply it to cloud computing. So that's what we did. We worked with DHS, we worked with NSA, we worked under the ISIMSI, the Information Security and Identity Management Committee, under the Federal CIO Council. And DHS had published a CSERS publication describing sort of best-of-breed continuous monitoring for the government, at least civilian government. And that was a good first start, but it wasn't complete. It didn't have everything we needed to actually build continuous monitoring systems. And so we worked together jointly on a revised reference model that went from a reference, it went from a definition to an enterprise architecture to a subsystem model to a technical communication model to actual workflows, interfaces, and product specifications. Very ambitious effort, I think, which means it's higher risk. But also I realized that unless we tried to build such a thing, that we couldn't solve the problem. We've got multiple security tools from different vendors. We need to normalize that data and bring it together. Throughout the government, we have a lot of fiercely independent units using different products, and we're never going to make them all use one tool. So somehow, we need to enable them to use their existing security products. We need to enable them to then use those security products to compose continuous monitoring instantiations. And then we need those instantiations to be interoperable. We need to be able to create a hierarchy within the government of data moving up, abstracted data, by the way, not the actual details, so that we can support operations at the lowest level, agency management at a higher level, maybe U.S. Cyber Command at another level, Cyberscope, DHS at the other, even higher level, and eventually giving sort of a dashboard for continuous monitoring for the federal CIO to show the status of the entire federal government. That's the problem we've been trying to solve. Oh, and by the way, what if we don't have the data we need? What if somebody up top says, hey, I see something I don't understand, I want to ask a question, I want to do a data call. We need the ability to then to ask that question down and get the data back up that we need. And if that data hasn't been collected, we need to task security tools to go collect it. So what's interesting is this is a hard problem. I argue it's a necessary one. Here's the enterprise architecture for it that came out of the NSA that I modified slightly. And I don't want to take up too much of your time, and so I'm going to breeze through this and then ask for general questions. But sort of here's an enterprise architecture showing people, process, technology, environment, collecting that data, aggregating it, doing sort of a focused aggregation up, sending queries back down, supporting lots of different consumer presentations for different consumers, making decisions based on lots of drivers. In a nutshell, that's sort of what it is. But remember here, we don't want to procure a single one thing for the government. We want to procure an ecosystem of tools that can work together. And the DHS continuous monitoring's blanket purchase agreement, the SARE Tier 3, lays a foundation for a lot of what we want in this vision. So it's a first step, kind of baby steps. The full vision will take years to realize. The Department of State, what they've done, actually, with what we have today, somebody could replicate what Department of State has done in a more standardized way using this model today. But that full vision that I've been giving you will take some work. Certainly, we want a component-based approach. We want a hierarchy. We want those queries going down, the answers going up. We want a task tools. Here's a quick view of sort of the subsystem model and high level, who might communicate with who. Christy? I'm going to ignore you because Parham gave me special timing instructions. Thank you. I got the red signs. I had to say that. In the past, she's come in here and I just didn't even see her. So I had to apologize afterwards. Okay. And so we've drilled this down, and we've identified 4 different interfaces needed to make this model work, one of which we don't really need. It just helps componentize things. So 3 of which we need. One of them we already have, and that leaves 2 standards-based interfaces that we need to develop and get into vendor products for that vision that I gave you to become a reality. So here's the hierarchical model. And I'm going to really go through this quickly. We created this model for enterprise architecture, enterprise data centers, or networks. And then we thought, okay, does this apply to cloud? And the short answer is yes. I won't go, I'm just going to skip through the slides. Evidently, you can download these and read them if you would like. And the short answer, though, clouds often have multiple data centers in sort of a natural hierarchy. Especially clouds built on clouds have a natural hierarchy. SLAs represent policy. Our continuous monitoring model represents digital policy. I didn't go into that aspect of it, but it represents sending a digital policy down, giving it to security tools, and seeing then the differences. So if clouds have hierarchies, if we need to abstract data away from the details so that cloud customers don't see too much of the security details, and if SLAs represent policy that we can send down, this model works perfectly for lots of different kinds of clouds. And I go through the different kinds here, composed clouds and all sorts of clouds. And I really should create a cloud taxonomy before showing you slides like that. But in short, I wanted to give you sort of a vision for where we, DHS, NSA, NIST, are trying to move the government towards interoperable, federated, continuous monitoring instances and applying that to cloud. And in part, I wanted to tell you that because I have this interesting work history where every year and a half or 2 years, usually involuntarily, but I get switched to something completely new. And so this may be my last chance to talk about this, because my friend Dave Waltermeyer is now in charge of all of this. And the cloud program is, of course, as you may know, is now Don Leaf, who's the senior executive for cloud at NIST. So in my next life, for those of you that have seen me before, I think it was most half of this room, if you see me again, we'll talk about NoSQL databases and big data analysis of security issues. So that'll be fun. That'll be my new life. But back to my old life, before I move on, this is your chance to ask any questions. And then At 6 o'clock, we'll all get drinks. Yeah, so we have, according to Parham's timing, we've got 13 minutes if you want to ask any questions. Mm-hmm. Have you contemplated those kind of tools and whether they would be leveraged? I have. So I've been going around to conferences in the last year talking to security vendors about their products. And many times when I present this architecture or the model, I end up with an irate vendor. Because the vendor says, well, I already do continuous monitoring. And the first hurdle to get over is to explain to them that, yeah, you do continuous monitoring, and that's great. But do you do it for the full breadth of products that are used out there? And with some of them, the answer is, oh, yeah, we cover a lot. And then the next hurdle is, well, do you realize, vendor, that we're not trying to invent anything new here? And I take the vendor's product, and I show them how they intersect with a lot of the requirements that are in this model. And the good news is that I believe that the vendor community already does a lot of what we, the government, want done with interoperable, federated enterprise continuous monitoring architectures. What they don't do, in a broad generalization, they don't do hierarchical communication well. They may have a limited hierarchy with a limited data communication, but they don't have arbitrary data hierarchies where we can abstract information going up. They also typically don't have the ability to send arbitrary queries down that hierarchy, especially for data repositories covering multiple tools. And they typically don't have the ability then to task a sensor to collect new data that we need if the sensor is not already collecting it. And lastly, if I was going to sort of list off highlights of what I'd like the vendor community to work on, many of them don't do true data normalization. What they do is they take security data and they convert it into their own proprietary format, which means we can't then pull it up into some other product's database and use it for some other purpose. So we can't create that hierarchy of interoperable instances composed of lots of different vendor products. and there's one more. Vendor products typically think that they know how to do the security. And they do, they do, but they don't know our enterprises. So they want to tell us their security findings. And that's great, we want to know that, but we also want to know the raw data so that we can do our own analysis relative to our own enterprise architecture and situation. And especially when you start bringing in data from multiple security tools from multiple vendors, you ideally want more of the raw data, not the findings. So that would be my last sort of area that the vendor community can work on. So one reason that I've been moved off of this work is because the remaining technical gaps that exist revolve around defining interfaces and communication specifications for the vendor community to adopt. And my friend Dave Waltemeyer has a long history in doing that. He's the lead SCAP engineer, and he's going to push that forward, and I'm sure we'll do a brilliant job. So anyway, so that's part of that story. That was a good question. Yes, another one. Mm-hmm.
Are there tools available or technology available to try and get a handle on that?
I love cloud security tools. I'm being sarcastic here. Actually, I do love them. They're needed. Whenever I meet a cloud security vendor, I get excited because I think they're going to provide me defense in depth to help me with the hypervisor uncertainty, the security uncertainty around hypervisors. And invariably, the cloud security vendor provides security add-ons for identity management, for all sorts of different monitoring. They hook into the hypervisor to get better data feeds, but I've never yet met a cloud security provider that provides me defense in depth in case the hypervisor itself has been broken. Does such a tool exist? Please educate me. Feel free to tell me I'm an idiot and educate me, but yeah, I don't know of any. So that's my frustration there. Okay. 7 minutes left. 27 minutes until the free bar opens over here. Have a room for a couple more? Yes?
So, in regards to one of the difficult areas of the cloud is data spills and procedures associated with it and kind of multi-tenant pool of storage.
Yes.
What have you seen as far as approaches to handle that? When you deal with, even in best laid plans, not planning to use the cloud computing environment for sensitive data. Data spills occur, and therefore you have to have those procedures that you have to put in place to be intelligent if you happen to be an integrator with that.
Yes.
They happen.
Mm-hmm.
So what do you recommend as far as how to cope with those kind of requirements where you're not going to get access to the media
Mm-hmm.
and be able to wipe it according to that agency?
Right. And so data spills, we're talking about putting classified data accidentally, where it shouldn't be. And so yes, my friends in particular at Department of Energy has hammered home that that's an important thing into my head. And I know it's important, and I don't know of any cloud provider that has a good answer for that, which may be another reason why government is so interested in private clouds. Because while the private cloud may not be more secure, we control it. And we can put in all the bells and whistles and knobs and widgets that we want to meet our security needs. So while across government, we may not be as unique and special as we think we are, as a government as a whole, we do have some unusual requirements that cloud providers aren't used to meeting. And on that note, cloud providers sometimes say, oh, well, we delete data using the NIST guidance. And I say, great, you're using NIST. That's wonderful. I've read the document. It's a thorough scheme. It meets DoD standards, I think. And the answer sometimes is, well, they only use that when they decommission a disk. So you have to ask when they're going to use it. But yeah, that's a tough issue.
And we have time for one more question.
Yeah, one more.
The bar won't open faster if you don't ask a question. So,
Hey guys, I want to thank you very much for being here. It was an absolute pleasure to be able to talk to you. Thank you.
Thank you, Peter. All right.